So here's the problem. The limit as x approaches 4 and the absolute value of x minus 4 over x minus 4. So what you need to do is you need to, with all limits, just plug it in. So try it. So 4 minus 4 equals 0 and 4 minus 4 is 0. So 0 over 0, that's an indeterminate, and we need to do something different. So if you have something over absolute value, the thing is you can't just like cancel these because of this absolute value. So we need a way to get rid of this. So what we do is we just find equations that will like take the place of this. Therefore, we can get rid of it. But at the same time, maintaining the exact thing it does. So here's what happens. So to get rid of this, we have x minus 4 equals, and then all I did was I put x minus 4, right? So I said it is any number that is greater than or equal to 4, it will still maintain the equation. Meaning, so let's say I said it's greater than or equal to 4, any number. So if we plug in 4, right? 4 minus 4 is 0. So if we plug in 4 here, it should have the same answer. So 4 minus 4 is 0. Let's try 5. If we plug in 5, 5 minus 4 is 1. Plug in here, 5 minus 4 is 1. So this equation is good. So what about numbers less than 4, right? So if we do the same thing, so if we have a number less than 4, let's say 3, right? We plug in 3 here. 3 minus 4 is negative 1, but the absolute value takes care of it. But here, if I didn't have this minus sign, if I just put in 3 minus 4 is negative 1. So here it's negative 1, and here it's positive 1. So we need something to get rid of it. Therefore, I added a negative sign. So now, if I put in 3, it's 3 minus 4, and that will be negative 1 times a negative will be a positive 1. Therefore, this equation and this equation are the same if I plug in any number less than 4. And the reason, and this is a piecewise function, and that's why this doesn't equal 4, because here it equals 4, but it doesn't. Because if both of these equal 4, then you can't have a piecewise function. So next, so since now we separated into two different equations, we have to come at this limit from the left and the right. And if the limit equals the same number from the left and the right, then it exists. So let's try it. So all this means as the limit approaches 4 from the left. So I wrote here, a negative here just means to the left, and a positive here means to the right. So limit as x approaches 4 to the left. Okay. So now, and I drew this. I drew this to help you with this. So if we're coming from 4 from the left, what does that mean? If we're coming from the left, that means we need numbers that are less than 4. Which equation gives us an equation that is less than 4? This one. Because it's this equation less than 4. So these numbers are all less than 4. So it'll give us 3, 2, stuff like that. So all we do is, since I said this is equal to these equations, we plug in the place of x absolute value, we plug in the same thing that I wrote here. So this equals that. So all I did was I substituted in. Now, since these two are exactly the same, I can cancel these. So, and here, since don't forget about this one, I would remain with a negative 1. Now, if you take the limit of just a number, it doesn't have any x's, it's just that number. So the limit as x approaches 4 to the left of negative 1 is just negative 1. So if it's just a number, nothing else, it's just that number, right? Okay, so now it's the limit as x approaches 4 from the right. Remember from this chart, plus just means to the right. So what do we do? All I did was look at this table, right? And then I saw that I'm wanting from 4 from the right. So it's an equation that comes from the right. So which equation fits that? Numbers that are greater than 4? This one. Because this is all numbers that are greater than or equal to 4. So I'm going to choose this equation. And all I'm going to do is substitute this for this. So the original equation was this. All I'm going to do is put this in its place. Okay, so that's what I did here. I put that equation in its place. So now these two cancel, right? So because they're the same thing, they cancel and they make 1. Once again, if you have a limit just to a number without any x's, it's just that number. So now what happens? Well, we just determined that from the left it approaches -1, and from the right it approaches 1. So since these two are different numbers, this limit does not exist. So overall, from this equation, this number does not exist. So I hope that helped, and thanks for watching.